Hi guys, John here, and today we're going to create 2048. This is a relatively simple project, but super fun. The result is this incredibly addictive game that you might remember from the mid-2010s. So we can check out our starting point here. Just have a simple scaffold with a tan background color. This color comes from up here where I defined a bunch of colors. So this is just a really simple mapping of if the tile's value is, 32 for instance, then the color of the tile will be this color. And yeah, we just got we got an app here, material app, and our main widget where we're gonna be doing most of our work. So let's kick this off by making the background. I'm gonna introduce a new value called grid size. This is basically just going to be the width of the screen minus some padding value times 2. I'm just going to use 16. This grid is going to be padded a little bit. And I just want to add a nice decoration here. All of the rectangles in the game have these rounded corners. And then let's just center this. Next thing I want to do is just add a blank spot for each tile. So let's define our tile class. This is a pretty simple class. It's just going to have its X and Y coordinate, and it's going to track the tile's value. As tiles merge together, their values are going to change. Now in the real game, all of these values are animated, so I'm going to go ahead and add the animations now. I'm also going to add a scale animated value. And this is just for when the tiles merge together, they kind of expand a little bit. And when tiles are created, I want to set these animation values to something reasonable. So these are the values when the tile is at rest. Okay, let's make the grid. We're going to need a 2D array of tiles. In order to do this, I can use list generate, where you specify a length and a function that will create each element in the array. So for the outer array, that's going to be our rows. Each row is itself going to be a list. So this will be the Y coordinate, this will be the X coordinate, and each item in the row is just going to be a tile. I'm going to create a nice convenience function here for getting the flattened grid. So in order to flatten a list of lists, you can use expand. So now we can create our grid. Okay, I want to draw my tiles, but first I need to know how big each tile is. Let's create a tile size. It's just going to be our grid size minus some padding times 2 because padding is on both sides, and then divided by 4 because there's 4 tiles per row and column. Let's add empty spaces for each of our tiles. They're just going to be positioned in the grid using the tile's X and Y coordinate. I can set a width and height on these as well, and it's just going to be the tile size. And the tile is going to be centered within this space. And as I mentioned before, the tile is going to have a little bit of buffer on either side, so the actual width is going to be the tile size minus this buffer times 2, because it's on both sides. And just like our grid background, we'll use a decoration. Okay, that looks pretty nice. Now what I want to do is draw the actual tiles. So in order to do that, I need to set up a few things. Firstly, I just need to set some tiles to some other value besides 0. because I don't want to draw 0 tiles. And then I'm gonna go through my tiles and just reset their animations so that the animated number gets updated. And now I'm actually going to add my animation controller because, as I've mentioned, all of these tiles are going to be animated. Let's initialize this. Now I can use that controller to draw animated widgets. We're going to do something very similar to these backgrounds, so I will copy this to make my life easier. But instead of just drawing a positioned widget, I'm going to draw an animated builder. I'm going to check the tile's value to make sure that it's not 0. And if it is 0, I'm just going to draw a size box, which will basically just draw nothing. If the value's not 0, then I'm going to draw the actual tile. The tile's color is going to be num tile color of the tile's animated value. So you can see these 2 tiles are now updated with the correct color. Let's draw the number inside. Okay, there's our number. Let's style this a little bit so it doesn't look so silly. Okay, I like that look, but I want to change these colors. What I will do is I'll say the color, if the value is less than or equal to 4, then it will be gray. Otherwise, I think white is a nice looking color. So you can see now these tiles look pretty nice. Let's implement the swiping. For the swiping, we can just wrap our stack in a gesture detector. And the events we want to listen for are on vertical drag end and on horizontal drag end. And we can check the velocity on the details in order to determine if we actually have a swipe. I've chosen these values after playing with this for a little bit. Horizontal will be similar, except we'll be checking the x coordinate. Before we can actually do the swipe, we should add in some check to see if a swipe is possible. I'll do the left swipe first because it's the easiest to implement. And what this will look like is for each row, we need to perform a check to see if that row can swipe. We'll implement this in just a minute. For now, let's return false. We can simplify this. To determine if we can swipe right, it's the same as knowing if we can swipe left, except we need to reverse each of our rows. And swiping down and up is also very similar. In order to know if we can swipe up, I'm going to introduce a member called cols. This will just get our grid as a list of columns. I'll put this up here next to my flattened. What this function will do is basically just rotate the grid so that instead of looking at each row, you'll be looking at each column. So now this is just the same as can swipe left, except instead of looking at the rows, we're looking at the columns. And can swipe down is going to be the same as can swipe right, where we need to look at the columns reversed. Now let's implement our valid swipe method. I want to iterate over every item in this list. And for each item, if I encounter a 0, all I have to do is check the rest of the list for a value. You can think of it by looking at this 4. If any of these spots to the left of the 4 are blank, and I am swiping left, that would be a valid swipe. So if tiles at I dot value is 0, then I just need to check if any of the rest of the tiles, so I'll skip I plus 1 tiles, that will effectively check the rest. I need to check if any of them are non-zero. And if this is true, then I know that this is a valid swipe. If the tile is not equal to 0, then I have to see if a valid merge can take place. The way I can do that is I find the next non-zero tile. Once again, I'll skip the current tile plus 1 just so that I don't look at all of the tiles I've already looked at. I'm going to find the first tile where the value is not 0. And I need to provide an or else, which will return null. If I don't provide this or else, this function would throw an exception if it didn't find an element that satisfied this condition. Let's shorten this a little bit. So if next non-zero is not equal null and the value is the same, then this is a merging situation. So I know once again that this is a valid swipe. So if none of these conditions are found, I can safely return false. Now we can go through our gesture detector and update all of those conditionals with these methods. Alright, now let's implement our actual swipe function. I'm going to create a function called doSwipe, and I'm going to pass in the actual swipe function itself, and you'll see what I'm talking about. But basically I want one function that manages the entire swipe and another set of functions that do individual types of swipes, like up, down, left, right. Inside this function, I'm going to be setting the state. I'm going to call the passed-in swipe function, and then eventually we're going to add a new tile to the grid, because that's how the game works, and then we're going to allow our animations to take place. So let's implement this swipe function, or I should say these 4 swipe functions. It's going to look similar to these, so I'll put them right underneath. Once again, swipe left is the simplest. Just need to look at each member of the grid, each row in the grid, and call some function on each row, which I am going to call merge tiles. So same with before, where when we're swiping right, we just need to map all of our rows and reverse them. Now we can implement our merge function. This is the most complex part of this project, so we'll go through it slowly, and I'll use these 4 different examples to show how this algorithm functions. The basic idea of the algorithm is to go through all 4 spaces, so we can just do a conventional for loop here, and we're trying to determine what value is going to wind up in that space. So the first step when we're looking at each space is going to be to find the next non-zero tile, and it might actually be at the space we're looking for, but it won't necessarily be there, so we need to go ahead and look through the rest of the spaces. So we can skip up until I to make sure that we're skipping over spaces we've already figured out, and then we just want to skip while the value is 0, because we don't care about tiles whose value are 0. The first tile in this list, at a minimum, is going to slide over to that spot. Now, as I mentioned before, it might already be in that spot, which means it doesn't have to slide, but we're still going to go ahead and look at it. So for these 4 examples, for the first example, this is just going to be this 2. So in this case, this 2 is already in the 0th spot, so it doesn't necessarily have to move, but we're not sure about that yet, so we'll let the algorithm continue. For the second case, it's going to be this 2, so we know that at a minimum this 2 needs to slide over. For the third case, it's going to go all the way to this 8 and find it. And for the fourth case, it's just going to find this 2, which once again is already in the right spot. But the next step of the algorithm is to find a merge tile. Now, a merge tile is the next non-zero tile that is equal to the value of tile t. So for our first step, let's just find the next non-zero tile. We can take our 2-check iterable, we can skip the first item, and then we can find the first where the value, we'll just use the value t here, and say the value is not equal to 0. And then just like the validate function, I can put an or else here and just return null if we don't find anything. Otherwise this will error. So this is the first non-zero tile, which if you look at the first example, the value is 4. 4 is not the same as 2, so it's not actually a valid merge. So we need to write a little if statement to handle that scenario. So if it's not equal to null, but also the value is not the same as t's value, then it's not a valid merge. So we can simply clear it out. Now for this if statement, we just want to check to see if we need to do anything. So for the case of the first example, the tile at position I is already t. So we actually don't need to do anything. So we'll put this little parenthetical here. But we would also need to do something if the merge tile is not null. So if you look at example 4, the 2 tile is already in the right spot, but there's also going to be a merge tile. So these 2 tiles are going to merge together, which means we still need to process the interior of this if statement. Okay, let's go through and do this. So we know that the result value of the tile at position 0 is going to at least be the value of t. So we'll just go ahead and set it to the value of t. Now later on we're going to come back here and we're going to animate t's position so that it looks like it slides over. Now if there is a merge tile, then our result value will have the merge tile's value added to it. We also need to move the merge tile over. Then we can safely set the merge tile's value to 0. And then after that, we can safely set t's value to 0. Now finally, the last thing we need to do is set the tile at position I. We need to set the value to the result value. And I made a mistake here. That's why there's a blue underline. I need to say plus equals. So this is the finished algorithm, except for the animations. We can go through it really quickly and just talk about what these 4 examples will work in a little bit more detail. So we'll start at position 0. For the first example, this 2-check iterable will just find the first 2. For the second example, it will find this 2. And for the third example, it will find this 8. And for the fourth, it will find this 2. So in all 4 cases, this 2-check is not empty will be true. We'll grab that first tile, and next we'll try to find a merge. For the first example, it will find 4. For the second example, it finds this 2. For the third example, it returns null because this or else kicks in. And for the fourth example, it finds this 2. So in the first example, this if conditional will null out the merge tile. Now we come to this line. This will be true for all but the first example, where the to tile is already in the right position and there is no merge. So for example 2, we get the value of t, we add in the value of merge, we set merge and t to 0, and then we set the tile at position 0 to 4. For the second example, we get the value 8, we skip this block because merge is null, we set this tile's value to 0, and the result value will be 8. And for the fourth example, we start with 2, merge is not equal to null, so we add 2, which gives us 4, we set the two tile values to 0, and the result is going to be 4. Now, let's talk about I equals 1. So for this first example, this to check will find 4. For the second example, to check will not find anything, it will be empty. For the third example, it will be empty once again. And for the fourth example, it will find this 2. In the first and fourth examples, to check will not be empty. For the other examples, this will get skipped over. So in the first example, we set t equal to 4. We cannot find a merge tile because we're already at the end. So inside this block, our final result value will be 4. We will zero out that tile, and we'll set the tile at position 1 to 4. For the last example, we set t to 2. We do find a merge tile. It is equal, so this does not kick in. So inside this block, we set our value to 2. We add in the merge tile's value to get 4, and we zero out the two tiles, and our final result is that a value of 4 winds up in position 1. Now the algorithm will continue to run for the remaining positions, but we won't find anything else. So at this point, we are done merging. So let's go ahead and restart our app. So swiping the grid does nothing. Now, the reason for that is we're kicking off our animation, but when the animation finishes, we're not resetting all of our tiles. So we need to add that. Okay, this looks okay. Let's just add a couple more values so that we can make sure some of our merging code is working. Alright, that looks roughly correct. Now let's work on the animations. I'm going to add functions to our tile class that describe each of the animations that are going to take place. The first is a move animation. So in this animation, we're simply moving to another location. And I'm going to need this parent in order to drive the animation. You'll see what I mean in just a second. So in this case, I'm just setting my animated X to a tween, where the begin point is the current location of the tile, and the end point is the new location of the tile. And I'm going to animate this. I'm going to use what's called a curved animation. I'll explain why in just a second. Curved animation requires a parent, so that's where this parent comes into play. And it also specifies a curve, where I'm going to use an interval. So just to explain what's going on here, I want this X position to move from my current position to the new position, but I want it to take place in the first half of the animation. And that's why I use this curved animation. The reason I want it to happen in the first half of the animation is I'm going to dedicate the second half of the animation to the merging and the tile expansion effect. So let's finish this. Animated Y is going to look pretty similar to this, except using the Y coordinate. Another animation I'm going to need is a bounce effect. This is just going to be a tween sequence. I'm going to expand outward and then shrink back down. Once again, I'm going to use this curved animation with this interval, but instead of 0 to 0.5, I'm going to say 0.5 to 1. And that's because this bounce animation will take place in the second half. I'm also going to add an animation for appearing. This will be for newly created tiles and will come into play in just a minute. And same deal, I'm going to animate this in the second half so I can just safely copy this. And lastly, I want to add an animation for changing the value of the tile. This one's slightly more interesting. I want it to take place in the second half of the animation. So I'm going to use this curve once again. But for the tween sequence items, I'm going to set the first tween's weight to be a very small number. And then the second tween's weight I'm going to set to be a much larger number. And this is because I don't want the value to actually change until the second half of the animation, but I want the value to change almost immediately. So this tween sequence will start in the second half, but the first part of the tween sequence will be over very quickly. So the effect will be that this number will change in the second half of the animation. Now let's call these functions. So we need to move our T tile. The parent is just going to be the animation controller, and the new position is going to be tile I's position. If there's a merge, we're also going to move the merge tile. The merge tile is going to bounce, and the merge tile is also going to change its number. Another thing we want to do is change T-tile's number to 0 so that it disappears. Because what this will look like is the two tiles will merge into one. T will disappear and the merge tile will be the remaining tile, but it will have the updated value. Okay, so these are our animations. Let's just see what this looks like. Okay, nice. We got some jank here. This doesn't look right at all. But I think I know why. I think when we're setting up our tiles, here we go. So instead of using e.x and e.y, I want to use the animated x value. All right, let's see if this improves it at all. Okay, cool. Now the next thing I'm noticing is that our size isn't coming into play, and that's because I'm not using it. So let's update this. e.scale.value. All right, cool. So now I have a little merge animation. Looks fun. All right, now in the real 2048 game, every time you swipe, a new tile appears. So let's implement that functionality. I'm going to go up to the top, and right next to my grid, I'm just going to add a list of tiles called toAdd. And this will hold tiles that have yet to be added. And what I can do at the end of every animation is add the tiles. So for each, and all I have to do here is just grab the grid at the tile's location and set its val to the tile's val. So this will basically copy over the tile that we're adding to our grid. Then I have to clear my toAdd because I've added them. Let's create a function in order to add a new tile. What this will have to do is find the empty spaces in our grid. We have to convert this to a list because I want to shuffle it, and you can't shuffle an iterable. Now we will add something to our toAdd list. And then we'll call that appear function that we wrote a couple minutes ago. And since the tile is added at the beginning of the animation, we'll actually see the tile appear during the merge phase. So now where do we call this function? Well, this is part of the reason I created that doSwipe method, because I want to call this function right after the swipe takes place. Finally, we need to render these newly added tiles. We can do that pretty easily just by adding them to this flattened grid whenever we're rendering. We can use a trick similar to how we created the flattened grid in the first place, where we pile them together into a list, then we just expand that list. So let's see if this works. All right, very satisfying. Okay, anyway, I think I will stop the video right there, but thank you so much for watching, and if you enjoyed it, please like and subscribe. It helps the channel grow, and I will see you in the next one. Bye-bye.